Inscribed angles and polygons. So some review first. Find the measure of each angle in the polygon. Well, at first we have a quadrilateral, which means all of these add up to 360. So I'm simply going to do 48, maybe. 48 plus 80 plus 2x plus 12, don't really need the parentheses, plus 2x minus 40, sorry, my bad, 20 equals 360. Okay, so I'm going to combine all my numbers, 48, 80, 12, and negative 20. All right. And I'm going to combine all my x's, 2x and 2x. So that's going to give me 4x plus 120 equals 360. If I subtract 120, I get 240. Divide by 4, x is 60. Now, that's not the answer. It said find the measure of each angle. So I need to plug in 60 here and 60 here. So if I do 2 times 60, that's 120. 120 plus 12 means this angle here is 132 degrees. And then again, 2 times 60 is 120. Minus 20 is 100 degrees. And if I add all those up, I don't know why I made this little 2 so small. If I add all 4 of those up, I will get 360. Now, in a triangle, they add up to 180. So I have 3a minus 2 plus just a plus 2a minus 16 equals 180. I'm going to combine my a's. So 3, 4, 5, 6a. Negative 2 minus 16 is negative 18. Now careful, I'm going to add 18 to both sides, which is 198. And if I divide by 6, I get a is 33. Not the answer. I need to plug it in. So clearly, a is just 33 here. If I plug in 33 here, 3 times 33 is 99. Minus 2 is 97. And if I double, I get 66. Minus 16 is 50. If I add all those up, I will get 180. So, new vocabulary. Inscribed angle and intercepted arc. An inscribed angle is an angle whose vertex is on a circle. So, in ABC here, this angle here, the vertex B is on the circle. And the sides AB and AC are chords. The arc that lies between the two lines, rays, or segments is called the intercepted arc. So we're talking about this piece right here, not the black line, this arc of the circle. If the endpoints of a chord or arc lie on the sides of an inscribed angle, then the chord or arc is said to subtend the angle. Fun vocabulary. So let's see what we have here. Angle B intercepts AC. Arc AC intercepts. So what that means is it kind of cuts it off here and here. It forms the angle. AC subtends angle B. So the arc subtends angle B, and the line segment AC subtends angle B. Now, an inscribed polygon is when all the vertices lie on the circle. And the circle around that shape we call a circumscribed. That means around. Circum means around, scribed means written. So the circle is drawn or written around the polygon. One more. Measure of an inscribed angle theorem. The measure of an inscribed angle is 1/2 the measure of its intercepted arc. Okay, so angle ADB, this right here, this angle right here, is half whatever that arc is. So the measure of angle T, okay, that's right here. Whoops. That's right here. Okay? Angle T, the intercepted arc is 48. All right? So remember, the relationship is 1/2. So this is 24 degrees. The measure of QR. Now, QR is going to take a little bit of work. So let's look at this first. The measure of this right here, okay, is going to be double this angle here. So that makes this 100 degrees. Now think about it. TR is a diameter, which means the arc TR is 180 degrees because it's half the circle. Well, if that's all 180 and this is 100, that means this here is 80. So it's one of those ones we have to do a little bit of work to work backwards to find the answer, but not too challenging. Just think of that 2-to-1 ratio every time. All right, find the measure of RS right here. Okay, well, RS is formed by SUR. This is 31, which is half of SR, which means this is 62 degrees. What do you notice about the angle STR and RUS? Well, since this arc SR is 62 and it's formed by the green angle, notice it's also that angle. That means STR is also 31 degrees. All right, inscribed angles of a circle theorem. If two inscribed angles of a circle intercept the same arc, the angles are congruent. That's what we just did. Okay? So we just proved that theorem. So given that the measure of angle E is 75, find the measure of angle F. Well, 75 is that right there. Okay? That's arc. So that means this is 150. First off. Now, we're trying to find the measure of angle F. Well, look at F. F is formed is GFH, which also does the same arc, which means the measure of angle F is also 75 degrees. Same thing we just did twice. Okay. Inscribed angle, I can read. Inscribed right triangle theorem. If a right triangle is inscribed in a circle, then the hypotenuse is the diameter. Okay? Conversely, if one side of an inscribed triangle is the diameter, then the triangle has to be a right angle, a right triangle. And the angle opposite the diameter is the right angle. All right? That's just a given. It has to be. Then we have inscribed quadrilateral theorem. So we just did a triangle, now a quadrilateral. A quadrilateral can be inscribed in a circle if and only if its opposite angles are supplementary. Okay? So, once again, we're going to have this situation here. I don't know why I wrote equals. Sorry. Opposite angles are going to add up to 180. So this one and this one are going to add up to 180. Or the other two, D and F. All right, here we go. So in the example 4, AB is a diameter. All right. That means this angle here must be 90. So all we do is say 2x equals 90. X equals 45. All right. Over here, remember, opposite angles are supplementary. So those two add up to 180, and these two add up to 180. So we have z plus 80 equals 180. So z is 100. And y plus 120 equals 180. Subtract 120 and you get y is 60. And that's it. A lot easier than it looks in all the verbiage and description.